The idea for this unit came about when I was watching one of our display layouts, and I had an automatic block teamed up with the automatic switching system like we commonly.
Hello, I'm James Ingram. This video was digitized from a 1992 videotape series named V9202.
This unit shown here is an automatic switching block. This is the newest of the 4 units we've talked about in this tape. The first unit being the automatic block of the magnetic type, second unit being the automatic block of the optical type, third unit being the automatic switching system, and this unit, the fourth unit, is called the automatic switching block. It's named for that reason because it combines both the circuitry of the automatic block and the automatic switching system into one integrated unit. This unit was just built recently, and it came back today. Today is on May 9th, 1992 from its first show, and it's seen perform as expected pretty much. What we've got up here in the front part of the unit, this circuitry right in here, is a circuitry from the automatic block. And then back here, the circuitry in the rear is a circuitry from the automatic switching system. So this thing has circuitry to perform both functions in one integrated unit. What we'll do next is actually put the block and the switching system next to this and try to show the similarities. The idea for this unit came about when I was watching one of our display layouts, and I had an automatic block teamed up with the automatic switching system like we commonly do, and I decided I can combine those functions in one unit and make it a little bit more compact and easier to set up. What we got here in front of this automatic switching block, this unit right down here, is our standard automatic block that we talked about earlier. This is the 944, which I'm calling the current standard model of automatic magnetic block. Back here in the rear is this automatic switching system, this being what I was calling the Model 122 automatic switching system. Let's try to point out the common parts. This circuitry here in the front is essentially this circuitry here taken from the block. Here is our track contact T2 for the block, which will go somewhere downstream in the track. Likewise, this automatic switching block has this track contact T2 here attached to the front of it also, which corresponds to the other track contact T2. The motor that operates a semaphore arm is here on the automatic switching block, and it's over here on the automatic block. The track contact T1 that sets the block to red is right here on the automatic block, and it's over here behind the semaphore arm on the automatic switching block. Likewise, you can see the front terminal blocks, the knife switch, the 2 sets of rheostats, the rear terminal block, and here the 1201 motor and the 1203 points, which do the switching on the automatic block. They're located up here on the automatic switching block. Moving to the automatic switch part of this unit, here's the motor of the automatic switching system that controls the 1203 points. On the automatic switching block, it's back here. Likewise, the knife switch here on the automatic switching system is over here on the automatic switching block plus the terminal block. The 4 1015Us, there's 2 here. Don't think they show up to it, but there's 2 1015Us here and 2 back here that define the 2 on-off sections that stop the trains on the 2 legs of the automatic switching system. Likewise, on the automatic block, the 1015Us, there's 1 back here, and there's a second one up here, and there's 1 back here and a second one up here. So these legs here are the parts that turn on off with this unit that start and stop trains. And then the two track contacts, which are laying loose here on the automatic switching system that actuate the switching functions on this unit, they're right here on the actual base. So you can see, I mentioned earlier in the discussion of the automatic switching system that this unit here was somewhat messy, and I didn't necessarily recommend building this. And what I did recommend was considering using the layout of the automatic switching block, which is what we're talking about now. And you can see this unit here, it's essentially all integrated into one piece, so it's has a lot less loose wires and loose parts hanging off of it than does the automatic switching system. And as I mentioned earlier, the reasons why you might want to use this automatic switching system, despite its messiness, is if you were doing automatic route selection, or if it just had an odd configuration. You can see with this unit, since it is all built together, you're restricted to having the two legs come in essentially in this shape, since they're all screwed down to the base, and it's not really convenient to reconfigure the shape of this thing. And likewise, you could use it for automatic route selection, but you would be again stuck with this shape of track work coming into the switch, plus these track contacts would have to be relocated somehow. Remember, for automatic route selection, we took these track contacts are laying back here, and we remotely located them to another location for automatic route selection. Likewise, to use this switching block for automatic route selection, we have to relocate these. Probably the easiest thing to do would be to actually disconnect these and put another pair in and wire those in. But for automatic passing siding operation combined with automatic block operation, this works quite well. The terminology for talking about these automatic switching blocks would be as follows. The model shown laying on the floor a minute ago was what I referred to as a model 163. The first two digits, the 1 and the 6, come from the 1600 switch. That's where that 16 comes from. And the 163 is a unit as shown with the switch and block circuitry. Also, units that could be built would be what I would call a model 162, would be just the switch part of it and the rheostats without the block circuitry. In other words, a model 162 would function as an automatic passing siding, do the flip-flop operation and operate two trains, but it wouldn't have the automatic block circuitry. Then you can also build a model 161 using the same layout of parts, but it would be a switch only and no rheostats. Just a simple flip-flop without any rheostat control. This model 162 still would have the rheostats to control voltage in the slowdown section and in the on-off sections. This model 163, as shown, that we're talking about and will demonstrate shortly, this one's really designed to operate three trains in a fairly interlocked manner, because it can hold basically two trains on the automatic switching part, and the block will take care of a third train. So we can operate three large trains in a fairly interlocked manner, and sometimes you can operate even more trains than three, because it is a block and it'll keep spacing trains. If the loop is large enough, you can operate more than three trains, although you don't really have an interlocked operation anymore.